So the next topic I'm going to talk about is the average value of a function. Okay, so we have this formula for the average value of f. So let me put in an f here. So if f is integrable on some interval, the average value of f is given by this formula here. And so what this average value is, so we know what this definite interval is from a to b if f is, let's think of f as being non-negative. Okay, and I'm going to set this quantity here equal to h. All right, and let's go over here now to our picture. So if we have our function f, I mark off a and b. We know that that definite interval gives us the value of this area. All right, so now let's take a look at this formula here. If I were to rearrange this formula, if I were to write that the integral, if I were to multiply by b minus a, we would have that the integral from a to b of f of x dx equals h times b minus a. So what is this h times b minus a? I mean, h is just a number, right? And b minus a, well, that's the width of this base here. So h is kind of like the height of a rectangle, all right, that has the same area as this area under the curve here. So h is basically going to be somewhere around, so imagine you can see how much area is here under the curve. Okay. Now find a rectangle. Think of finding a rectangle that has that same area and also the same base that is b minus a as its base. So that would be, if I just try to eyeball it, I would probably do something like that. Okay, maybe that's a little bit too high, but this would be h. Okay, and the area of that rectangle, okay, which is b minus a times h, would be equal to the area under that curve. Okay, and so this value h is considered the average value of f. Okay, and so just by looking at that picture, it should make some sense. Okay, so for example, let's find the average value. So find the average value of f of x equals cosine x on the interval from 0 to pi over 2. Okay? And so we can draw a picture of this, and you can think of what cosine x is. All right? It's 1 at 0, and then it goes down to 0. Okay, so it's got, so that area, if we were to just compute the interval from 0 to pi over 2 of cosine, we know that that represents that area under the curve. Okay, because cosine is positive on that interval. But what we want to do is we want to find the average value of cosine on that interval. So the picture would look like this. So cosine starts at 1, and it goes down to 0, and it looks something like that. Okay, so this is pi over 2. This here on the y-axis is 1. Here's the area under the curve, and we're going to find a rectangle that has base pi over 2 and a fixed height, where that rectangle has the same area as that. Okay, so we would basically do this, use this formula. 1 over b minus a, in this case it's pi over 2 minus 0, and then integrate from 0 to pi over 2, cosine of x dx. Okay, so this equals 1 over pi over 2, which we'll simplify in a moment, antiderivative of cosine x. So I know it's sine x, I'm not sure, so we don't need a sign change, right? It would just be sine of x, since the derivative of sine of x is cosine x. Okay? I would set up to use that fundamental theorem of calculus, okay, with these limits of integration. And so this is going to equal, all right, I'm going to take care of that fraction there. It's 2 over pi. And then it is going to be sine of pi over 2 minus sine of 0 in parentheses here. Of course, the sine of 0 is 0. And the sine of pi over 2, well, that's 1. And so our final answer is 2 over